Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn how data traffic flows in OTV. So in this session, we will learn how data traffic, unicast traffic or multicast traffic is delivered over OTV, overlay tunnel. So let's see how, unicast traffic is first sent. So let's suppose, I have a site 1, right? And I have a site 2. Site 1, host A wants to send a traffic to host B or host C, we can say, right? So host A wants to send a traffic to host C at site 2, and this is site 1. Now, once the Ethernet frame reaches here, the access switch forward that Ethernet frame to the edge switch where the OTV is configured. Now the edge switch will consult that, okay, where this MAC C is connected. It will see that, okay, the MAC C is connected over IPB, which is via OTV tunnel. So the Ethernet frame is encapsulated with the OTV header, right? Where the source IP is IPA and destination IP is IPB. And then over the join interface, it will be routed to send to, join interface of site 2 edge device. Now, once the packet receives here, the packet will be decapsulated. Again, this edge device will see that, okay, where this Ethernet frame is, connected. It will see that, okay, it has to be sent across, this port, trunk port. It will send this packet, and finally the Ethernet frame is handed to the host C. So this is how, OTV unicast traffic is sent. In the OTV over unicast transport. So now let's understand the OTV frame format. So in the OTV, frame format, my Ethernet header, right, is encapsulated with the OTV header. We say it as a OTV SIM, and then the Ethernet header. So total 42 bytes of header is attached to my original Ethernet frame. So out of which the 8 byte is, my OTV SIM. The OTV SIM contains the VLAN ID. The VLAN ID it takes, from this L2 header. It will take the 802.H1Q. It will remove this, header, and it will insert here, right? So OTV contains the VLAN and overlay ID information, and also, all the OTV frames are set with DF, so don't fragment, bit is enabled. So that means your fragmentation and reassembling of the packet is not done into the OTV infrastructure. So in that case, you have to maintain your MTU size all across your layer 3 interfaces like jumbo frame or 92200 byte. Okay, now let's see how the data plane is done on the multicast for the multicast traffic. So here we will learn how multicast traffic flow from source to destination via multicast enabled transport or unicast enabled transport. So let's suppose I have a two type of transport. One is the multicast enabled transport and another one is unicast enabled transport. So first we will see how the data traffic flows in the multicast traffic is sent over multicast enabled transport. So in order to send the multicast traffic over multicast enabled transport, a set of SSM source specific multicast group is used, that is configured under the logical interface overlay interface of edge device. So remember in previous sections when we were learning the OTV concepts and terminologies, there I said that under overlay interface, two type of multicast group is configured. One is for the control plane and another one is called data plane. For control plane, ASM group is configured, and for the data plane, SSM group is configured. Now let's see, how the traffic is sent. So once the local OTV edge device receives the multicast traffic, it creates the mapping between G1, right, and a specific SSM group G2 available in the transport infrastructure, right? The range for SSM group is, we can say that SSM group range is 232.0.0.0/8, right? And enabled in by default once PIM is configured, right? So this is a first one, that as soon as the host starts sending a traffic, streaming to the multicast G1 group, the G1, the edge device at the site 1, it will map to the G2. And what is G2? G2 is the multicast IP address from SSM range. Okay. Right now this mapping is communicated. Now once the mapping is done, so for source G1 group, it has mapped to G2 for SSM, right? So source is streaming on a group G1, and then your source is the G1 is mapped to G2 via edge device. Now once this mapping is done, this mapping is communicated to the all edge device by OTV control plane, and this mapping also specifies specific VLAN to which multicast source belong and the IP address of the OTB edge device that created mapping. Now this information is sent here and here, right? And this information contains the mapping G1 to G2, VLAN of source, and site 1 join interface IP address. So these information is sent to site 3 also and site 2 also. So now let's see how the neighborship is formed. Now once now let's suppose the client on site 2, right, sends the IGMP join report to join the G1 group. So let's suppose this client is interested to receive the multicast stream for G1 group, right? Now, which indicates that host on a site 2 is interested to receive the multicast frame stream sent by site 1 source. So this client at site 2 joins the G1 group. Now, once the client joins the G1 group, the OTV device at site 2 snoops the IGMP message. So it will send the IGMP join, right? It will snoop the IGMP join message and note that there is an active receiver interested for group G1 stream belonging to VLAN X. So let's suppose, or I can say, let's suppose it a VLAN 10, right? So once the join message is received to site 2 edge device, it will snoop it and it will note that there is an active receiver interested for G1. Now once the it came to know that I have a interested a candidate to listen for group G1, the OTB edge device at site 2 sends the OTV control message to all remote sites that there is an active receiver for group G1. So what it will do, it will send a update that okay, I am having a active receiver for group G1. Once the OTV edge device at site 1 receives the GM update, so it will send a GM update, it will receive the GM update, site 1 will receive the GM update, and what it will do, it will update the outgoing multicast outgoing list that for group G1 I have to send a traffic to overlay to the site 2, right? Okay. Now the OTV edge device, once the OIA list has been modified at the site 1 edge device, the OTV device at site 2, it already has a mapping information of G1 group to G2, right? So it already has a mapping information because at first step it has already received. What it will do, it will create a IGMP join report, IGMP v3 join report for IPA to G2 to create a SSM tree. Okay. So let's repeat it. At first step, I have a client. I want to receive, multicast stream for group G1. I will send a join message, right? Once the site edge device at site 2 will receive the join interface, it will snoop it, and side by side it will send a GM update to site 1 that that I have an interested candidate to listen, to receive the multicast stream for group G1. Once this GM update is reached to site 1, the site 1 edge device will update its OIA list, saying that for group G1, where I have mapping for G2, I have to send this traffic for overlay to the overlay interface connecting to site 2. Now, once it is done, the site 2 will generate a IGMP v3 report to IPA group 2 to create a SSM tree, and that report will be sent to site 1. Doing this, a SSM tree is created. Now, once the SSM tree is created, and by doing this, once the SSM tree is built across multicast infrastructure, and this SSM tree will be further used to transport multicast stream sending at G1. Now, once the tree is created, so let's see how the multicast streams is delivered. So let's suppose site 1 is streaming at G1, right? Now, once this stream reaches to edge device, the edge device will look the OIL interface, OIL table, and once the OIL table is done, lookup is done, there will be a hit, and then edge device will encapsulate the multicast frame with the source IP, that is IPA of its join interface, and the destination IP is G2. Why? Because your G1 is mapped to G2. So once the stream reaches here, it will look up the OIL list. It will say that, okay, I have a mapping and I have to send the traffic to the overlay because I have an interested candidate or a receiver at site 2. What it will do, it will encapsulate this multicast stream to the OTV header, having a source IP of IPA and multicast destination IP G2, and that will be sent to the multicast transport. And let's suppose at site 3 also I have a receiver, so this multicast stream will be sent to site 2 or site 3. Once this multicast stream encapsulated with the OTV header receives at site 2 and site 3, the site 2 and site 3 edge device will decapsulate it, and finally the original multicast traffic is sent to the receiver. So this is how your multicast traffic is sent across multicast infrastructure. Now let's see how the multicast traffic is unicasted or sent over unicast enabled transport. So in that case, client on a site 2 sends a IGMP report to join G1 group, right? So here the client at site 2 will send a join report, right, to join this G1 group. This information is sent to the site 2. Site 2 will it will snoop this IGMP packet because it already has a neighbor list, right? So I have a neighbor site 1 and a site 3 for which is reachable on a site A, and it is reachable on a site C, IPB. So what it will do, the OTV edge device on a site 2 snoops the IGMP report, confirms that there is an active receiver for a group G1 on a VLAN 100. So let's suppose on a client 1 is on a VLAN 100. Okay. This information is sent all across OTV edge remote sites via GM update, right? It will be sending GM update by using the unicast neighbor list which site 2 has. Now the site 1 edge device receives the GM update. It will update its OIL table saying that for group G1, I have to send a traffic to IPB because at site 2 IPB, I have an interested receiver, right? So this is how your OIL list is populated. Now, once your OIL list is populated, and the source at site 1 start streaming at G1 group. Once the stream reaches to the edge device at site A, edge device at site A will look up its data group mapping table where it says that, okay, for group G1, I have to send the traffic to, IPB and IPC because I have a receiver, interested receiver for this group at site 3 and 2. It will create a 2 unicast packet saying that source will be IPA, destination will be IPB of site 2, source will be IPA and destination will be IPC or of site 3, and then it is formally unicasted, routed to site 2 and site 3. Once the edge device receives this multicast OTV multicast packet, it will decapsulate it and it will send it to the receiver. Okay, so thank you for watching OTV data traffic flow. Thank you very much. Take care. Bye bye.